Hello friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about pipe welding. Types of welding. Electric arc welding is used for CS and SS pipes. Argon arc welding is used for SS pipes. Gas welding is used for copper tubes or lead-lined pipes. Arc welding is one of several fusion processes for joining metals. By applying intense heat, metal at the joint between two parts is melted and caused to intermix directly, or more commonly, with an intermediate molten filler metal. Upon cooling and solidification, a metallurgical bond is created. Since the joining is an intermixture of metals, the final weld potentially has the same strength properties as the metal of the parts. This is in sharp contrast to non-fusion processes of joining, i.e. soldering, braiding, etc., in which the mechanical and physical properties of the base materials cannot be duplicated at the joint. In arc welding, the intense heat needed to melt metal is produced by an electric arc. The arc is formed between the actual work and an electric stick or wire that is manually or mechanically guided along the joint. The electrode can either be a rod with the purpose of simply carrying the current between the tip and the work, or it may be a specially prepared rod-wool wire that not only conducts the current but also melts and supplies filler metal to the joint. Most welding in the manufacture of steel products uses the second type of electrode. Basic welding circuit. The basic arc welding circuit is an AC or DC power source, fitted with whatever controls may be needed, is connected by a work cable to the workpiece and by a hot cable to an electric holder of some type, which makes an electrical contact with the welding electrode. An arc is created across the gap when the energized circuit and the electric tip touches the workpiece and is withdrawn, yet still within close contact. The arc produces a temperature of about 6500 F at the tip. This heat melts both the base metal and the electrode, producing a pool of molten metal, sometimes called the crater. The crater solidifies behind the electrode as it is moved along the joint. The result is a fusion bond. Electric arc welding equipment. It can be single-phase transformer. It is not recommended as current is not steady. Two-phase transformer is recommended as current is bit steady. Generator is best to steady current. Nature of the arc. An arc is an electric current flowing between two electrodes through an ionized column of gas. A negatively charged cathode and a positively charged anode create the intense heat of the welding arc. Negative and positive ions are bounced off of each other in the plasma column at an accelerated rate. In welding, the arc not only provides the heat needed to melt the electrode and the base metal, but under certain conditions must also supply the means to transport the molten metal from the tip of the electrode to the work. Several mechanisms for metal transfer exist. Two of many examples include surface tension transfer. The drop of molten metal touches the molten metal pool and is drawn into it by surface tension. Spray arc. The drop is ejected from the molten metal at the electrode tip by an electric pinch propelling it to the molten pool. Selection of electrodes. For electric arc welding, electrodes coated with flux are used. Melting flux covers weld and avoids oxidation during welding. There are special electrodes for piping and general-purpose electrodes for structural work. Size is specified in gauge. 10 gauge is generally used. Welding rods are available in a variety of materials to match the material of the workpieces being welded. For argon arc SS wire coils are used. argon, which is an inert gas, acts as cover. For gas welding, wires or coils of same metal are used. Gas welding uses welding rods to introduce filler material into a weld. Welding rods for gas welding are coated with a flux material that vaporizes when heated. The vaporized flux displaces air from the weld location so that oxides are not included in the weld. Position of electric while welding. Bisect angle of two metal surfaces. Lead angle of electric should be 10 degrees in direction of travel. Distance of electric off metal surface for the arc gap should be equal to core diameter of electric. Amperage used for electrics of different gauges. For 12 gauge or 1 by 16 inch amperage used is 20 to 40 amperes. For 10 gauge or 3 by 32 inch amperage used is 30 to 80 amperes. For 8 gauge or 1 by 8 inch amperage used is 80 to 130 amperes. For 6 gauge or 5 by 32 inch amperage used is 150 to 180 amperes. Purposes of electric flux. It helps to establish an arc. It produces slag coating to shield weld while cooling. It protects metal under arc from atmosphere. It produces lensing gas like hydrogen or carbon dioxide. The appearance of good weld. It has a smooth weld surface after slag removal. It has even ripples. It has gloss or sheen to surface after removal of slag. It has a good penetration and has smooth slab coating. Common defect is pits which are formed due to moving too fast forward. There is no filling motion and arc gap can be too high. Defect due to uneven slab coating. Wrong type of electrode might be used. Excessive heat is generated as base metal is too hot from previous weld runs. Too much amperage for electrode. Uneven motion of electrode. Defect due to uneven ripples. Distance from electrode to metal is not being maintained constant. It changes arc gap. Travel speed not maintained due to constant shaking of hand while welding. Storage of electrodes. Coated electrodes are stored in cardboard boxes and packed in wooden cases. Generally box is issued. End butts used to set pipe gap. Avoid spillage of water on electrodes. Coils are stored in plastic bag. Argon arc is used for SS pipes. It is arc welding process that uses non-consumable tungsten electrode to produce a weld. Weld area is protected by inert shielding gas such as argon or helium. In this filler metal is normally used. Some welds, known as autogenous welds, do not require filler materials. Constant current welding power supply produces energy which is conducted across arc through columns of highly ionized gas and metal vapors known as plasma. It is used to weld thin sections of stainless steel and non-ferrous metals like aluminum, magnesium, or copper alloys. Process gives greater control over weld for stronger and higher quality welds. It is more complex and difficult to master, significantly slower than most other welding techniques. Related process, plasma arc welding, uses slightly different welding torch to create more focused welding arc and as a result is often automated. Shielding gas, argon and helium mixtures are frequently used as shielding gas. It can increase control of heat input while maintaining benefits of using argon. Mixtures are made with primarily helium, which is often about 75% or higher, and balance of argon. Mixtures increase speed and quality of AC welding of aluminum, and also make it easier to strike an arc. Argon and hydrogen mixture is used in mechanized welding of light gauge stainless steel, but hydrogen can cause porosity. Nitrogen is sometimes added to argon to help stabilize austenite in stainless steels and increase penetration when welding copper. Gases used for welding fuel before acetylene could be effectively produced and contained. Coal gas and hydrogen were used for gas welding. Today, gas welding is performed using LPG and acetylene. Oxyacetylene is the most common gas combination used in gas welding operations. Oxyacetylene welding combines oxygen gas and acetylene gas to create the flame. Acetylene provides the hottest flame of all gas welding fuels, and can't therefore be used to weld or cut thicker materials. However, acetylene is more expensive than most welding fuel gases. Braiding material is generally a coil. Flux is used for cleaning and covering weld. Type of welding process depends on type of flame. Flame is fed by pressurized fuel gas. Several different types of fuel gases can be used depending on application, availability, and cost. Gas welding operations center on torch that creates welding flame. Welder can adjust amount of gas being used by torch and oxygen used to feed flame. By controlling ratio of gas and oxygen, welder can create different flames with different characteristics, depending on material being welded. Welder uses filler rod coated with flux to add material to weld and to displace air from weld location. Like all welding processes, welder must wear protective clothing, welding mask, gloves, coverall clothing. No electricity is required to perform gas welding, so these systems are portable and can be used in remote locations that do not have electrical sources. Gases used for this type of welding are combustible and they must be stored and handled properly. Gas welding does not produce as much localized heat as arc welding, and quality of welds created by arc welding have resulted in decline of gas welding as primary welding process. Gas welding still remains an important part of welding and fabrication shops. Proper gas for cutting is done by LPG acetylene and oxygen. Plasma cutting for tough materials like stainless steel. Acetylene is most common gas used in gas welding operations. Acetylene welding combines oxygen gas and acetylene gas to create flame. Acetylene provides hottest flame of all gas welding fuels. It is used to weld or cut thicker materials. Acetylene is more expensive than most welding fuel gases. Welding rods for gas welding. It uses welding rods to introduce filler material into weld. Welding rods for gas welding are coated with flux material that vaporizes when heated. Vaporized flux displaces air from weld location so that oxides are not included in weld. Welding rods are available in a variety of materials to match material. Pipe end preparation. Plain ends are used for socket weld ends. These should be flat, remove scale. Beveled ends are used for butt weld ends. Grind end to prepare mirror finish beam. Welder qualification. Welder should pass qualification test. It is required for steam line welding, high pressure lines welding, petroleum lines welding. It is not required for water and air lines welding. Precautions for welding. Good ventilation must be provided. Helmet, jacket, and gloves must all be worn when welding to protect eyes and skin from being burnt. Ultraviolet rays. Cracked lens for welding helmets must be immediately replaced because of dangerous ultraviolet rays. Welding boots only. Use eye protection when shipping flag. Hot cables should be reported to instructor. If hot metal is to be let out after welding, label is as hot with soapstone. Do not weld on galvanized steel as it is dangerous to health because of the toxic zinc fumes. Do not weld near flammables. When through and leaving booth, turn power off. Suspend electric holders so they do not touch any metal when not in use. Complete one run with one rod. Clean flex of earlier run with wire brush. Grind run for radiography welding. Use tubes for pipes of large diameters. Do not use wet electrodes. Do not stop till one weld is complete. Heat treatment. In this process, weld is heated and allowed to cool. It removes stresses formed during welding. It is crucial for large diameter piping, oil and gas piping. It relieves stress due to welding of shoes, lugs, supports. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.